Well, hello everyone, and welcome to another video from the Canal Sidings Model Railway channel. I am going to do a slightly different video today. I'm afraid there'll be no trains running. We're sitting at my workbench, which I've cleared specially for the occasion. Yeah! We're going to talk about my thoughts for my new Inglethwite layout. Where I said I'm going to make the baseboards out of this stuff, which is blue Styrofoam. The advantage of it is it's very rigid, it's very hard to twist, but it weighs next to nothing. And as I've said before, what I intend to do is put 4mm cork. This isn't cork, this is a piece of 4mm MDF, but I intend to put 4mm cork on the top of it, and on the bottom of it I intend to put some 12mm by 35mm wood strips, simply to allow me to slide it on the shelf that I make, that I've talked about in the past, that's got to span 7 feet without any support. Okay. And because I haven't got very much room above Canal Sidings, the actual layout, when I've got it installed, then I have had to do a bit of lateral thinking on how I'm going to build these these baseboards for this layout. Now, as you can see, if I've got cork on top of there, and just, let me turn that around. I've got cork on top of there and just 2 inches there plus another 12mm underneath, then I've actually not got very much height in which to build my point motors. What I have to do, of course, is put the point motors on the bottom of the point, and that's what this is for. I've just cut this out as a almost point shaped piece. Needs a piece cut off that end, but that would sit on the baseboard like that, and I need to put a point motor underneath it at this end, of course, to operate here. I have actually already modified this Pico point so that it has no over centre spring, so it sits naturally in the centre. Now, I would normally use one of these, which is a Merg point motor mount, for mounting a servo. You've seen these before if you've watched my other videos. We mount a servo on there, like that. This is a separate piece here that comes through. Through that pivot point there we have an arm that pivots, which I don't happen to have. It does that. And the top of it moves backwards and forwards up there as the servo horn moves the bottom. The point operating wire is held in that hole and goes through a hole in the top of this piece and gives you that motion through the baseboard. So this goes through the baseboard. Obviously that pip shouldn't be there, it's just a bit of extra 3D printed material. However, when I put that in there, it's going to stick out of the bottom. It's got to go under that. I'll get rid of the point for a minute. It's got to go underneath that and be fixed to it, and it already sticks out of the bottom. Now, it doesn't stick out of the bottom that much, and is almost usable with one, but there's one problem. It's much wider than the actual point, and requires a wide piece of wood, which I'm hoping not to go quite as wide as that with the real thing. I'm hoping to get nearer a width like that, cut really close to there and really close to there. That's what I'm hoping to do. Whether I'll manage that or not, I don't know. But I've decided that that doesn't really cut the mustard. What we did find, and I have a friend and fellow Merg member, Hugo, who actually lives in the same village as I do, and he happened to notice me communicating or commenting on Merg and said, hey, we live in the same village. And we got together, and he's involved in a big garden layout and uses JMRI, and I'm involved in a smaller indoor layout that uses JMRI, so we got a massive amount in common at that point. But he informed me he has a 3D printer, and said that if I wanted anything printed to let him know. And I said, funny you should say that, Hugo, because I'm looking for some point motors to go in this thickness of board with a bit of clearance, and to be very easy to adjust and set up. Now, there's something else about these that isn't easy. Because the micro switch sits, to put it the right way up, the micro switches sit here or here, and this, the bottom of this arm operates the micro switches. They sit with their ends coming down this way, and it operates the micro switches that way. Because of that, you've got to set this up to set the point and then adjust the micro switch, which, if that's all the way up inside there in a hole in that, is going to be really difficult to do. If it's in a hole that's only the size of it, it'll be really difficult to adjust that micro switch. So another problem with that. What we did find, as I say, what Hugo found and pointed out to me, was that another Merg member has invented this, which I've just thrown on the floor, which Hugo printed one of so we can have a look at it. Now in this case, the servo fits here, like that, and if you can see up there, I'm not sure, you can see that the servo horn would fit in there onto the white protrusion of the servo, and that, when it turns with a screw in it, a screw in the servo horn, engages in this slot and moves this up and down, or sideways as it happens. And let's take the servo out again. I'm now the other side of it, the servo was in here, and there is a hole here which then goes up through the baseboard and allows that to operate the point. This suffers from even more width, because if I show you my piece of wood now, and this is far wider than I want, and look, the mounting holes are now outside of it. Plus the fact that the micro switches sit here and here, or here, or here, and are operated by these horns, and again they need adjusting after you've got the travel set up. So that was a bit of a non-starter as well. So I specified what I really wanted as a servo mounting to operate points, and we used the information from a guy called Dave Fenton. Now, if you know Dave Fenton, if you know Megapoints, then you know Dave Fenton, because he is the brains behind the Megapoint system. And it turns out that Dave Fenton is also a member of Merg now, and has made the main Megapoints module available as a Merg kit for about half the price of the built version. But further than that, that's not really the point of this story. Dave Fenton has got lots of videos up on YouTube, and he's got 2 or 3 of them that show you how he reckons you can operate a point with a servo. And what he does is he uses a piece of aluminium angle, 15 by 15 by 15 millimeters, and he just puts the servo into that aluminium angle. He cuts this end off, pushes the servo in, and it holds the servo, and then a horn on here, into the angle at the top he drills a hole, a 1 millimeter hole I think, gets a piece of piano wire, hooks it into the horn of the servo. The horn of the servo moves backwards and forwards, causes the wire to do this through the hole, pivoted at the hole in the angle, and operate the point. Now, all the conventional wisdom says that you make the wire size to the same size as the hole in the tie bar, which is there. Can't see it, it's there. Gets lost when you take the top off, it's there. And it's just over 1 millimetre. I think it's about 1.2, 1.3 millimetres. So everybody says let's use 1 millimetre piano wire to operate it, and that, sure enough, is what this version and this version would probably use. Now Dave, Fenton that is, took this a stage further and tried using his angle, his aluminium angle. He tried 0.6 millimetre piano wire, which is far more flexible than 1 millimetre, and he found it was still perfectly capable of operating the point, but he didn't have to adjust it at all. He could set the servo up to have the full 90 degrees of movement, that's plus or minus 45 from the centre point, and he could operate any kind of point. And there is a video which I'll give you a link to so you can see exactly what Dave's talking about. And I used that idea and sent that video link to Hugo so that he could have a look at it. And so therefore between us, but most of the mechanical design done by Hugo, we have come up with this. Now this, the green pieces are, the green parts are the 3D printed parts. There's that one piece there, and there's one piece there which I'll come to in a minute. So what we've got is, we've got the servo mounted on here, and that sits up on there, up under there, like that. You see it nowhere near comes to the bottom. The width of the mounting is less than now the width of the point, or actually almost exactly the width of the point at its extremities. We can put the 0.6 millimetre piano wire in here. It goes up through this hole here, which comes out the top there, and will go through the hole that I've already drilled in here and into the tie bar of the point. And we can operate the point knowing that with the full 90 degrees of the servo, which is unadjusted, it'll definitely operate the point. Now what Hugo has come up with is the brilliant idea of making the servo operate the micro switch as it crosses the centre point of its travel, which we always use. So if I put that on there, I can fix it, but this cam now will operate that micro switch as it crosses it. So we can go the full 90 degrees knowing that at that point, which is halfway through the travel, it operates the micro switch. Now we have a system where we don't need to adjust the micro switch. It will operate always around about the centre of the travel of the point blade as it crosses the centre. So what we have is a system that requires no adjustment. I can build it and make it work, and it will never go out of adjustment because adjustment is not necessary, it's not critical. And that's what I'm going to do next. I'm going to mount this here. It's pretty hard to hold it all together. I'm going to mount that there, and I'm going to mount this point on here like this, and I'm going to try 0.6 millimetre piano wire up through there, no adjustments whatsoever, and we'll see how it works. And of course that will fit easily on there. And my idea with this wood, with this MDF, is that it will be the same thickness as the cork that is all over the top of this. Yeah, there'll be cork all over the top. This is a gash piece, but there'll be cork all over the top of the of this material, of this foam, and what I will do, everywhere I want a point, I will make a piece that suits the size of the point, hopefully significantly smaller than this piece. I will then put that down where it needs to go. I will cut out the cork around it, and having done all of that, I will have all the points ready to lay. I can then glue the cork down to the top of this, leaving these holes free, and then we can mount the track and the points on top. We can lay the track and we can lay the points, and what I'll do then is I will spray the whole area with track colour, with all the track in place but not glued down, just held with a few pins, drawing pins, whatever. And that has the effect of weathering the track right from the start, but more importantly it will leave a shadow of where the tracks go all over the baseboard, so that we can easily put them back. And in particular it'll leave a shadow on here, so then I can pick that up, lay the point always in the shadow of the paint, so you'll be able to see you're in exactly the place it needs to be, and then I'll be able to fit the servo mechanism to the bottom of the point. It'll all be wired underneath the point, or the dropper wires. I'm going to wire the points DCC friendly through these links across here and to the crossing V, so I can bring these wires to the micro switch and the crossing V to the micro switch, and it's all in place, all installed. I can bring them through the bottom of this or under the top. I'm not sure exactly where the wires are going to go yet, but they can be relatively thin, so thin in fact that they could probably be dropped into little grooves that are cut in here, or to the other side more like. Don't know, haven't got all the way there yet, but I'm getting there as to how the points can be mounted. It's going to be a lot of work, but because it doesn't require any adjustment, it's unlikely you're going to have to lift the points ever, because that's the only way to get at them if anything goes wrong. However, of course, micro switches can fail, servos can fail, solder joints can be bad in the first place and go dry, or they can just break. So I need to be able to lift this piece up, and my intention for that is that at this end I will push the rails onto two insulated rail joiners, because you can't join these, and then I'll slide two metal rail joiners onto the outer two tracks, and at this end I'll slide two rail joiners on, and that will give you electrical connection to the point. I know it's through rail joiners, but there's two for each rail, one at each end, and both pieces of track either side of it can have power fed to them. And if I did get any problems, there's nothing to stop me from taking a connection off the micro switch and taking two dropper wires to power the point externally. Normally the only thing sticking down the bottom and through the hole that I'm going to have to cut in here would be this servo operating wire, which we plug into. At the moment I quite favour trying to buy a megapoints module to do the job, but not absolutely sure yet. So that's the first part of this video. What I'm going to do now is I'm going to go away and try and get all this mounted. I'm not going to cut a piece of hole in the. I'm not going to cut a hole in the piece of foam. I'm just going to try and make this assembly up, complete with a bit of 0.6mm piano wire, which only came yesterday. So not yesterday, the day before yesterday. So I'm not able to do anything with that at the moment. I also didn't have the two screws that are required to mount the micro switch. They're M2 by 10mm. This screw I happen to have. It's a number 0 by 4.75mm self-tapping screw. I use those myself, but I didn't have any M2 by 10s. I do now. I buy most of my screws from a company called Model Fixings. They're not the cheapest, but their selection of screws, small things like that, is brilliant, and they're very quick. So I think 100 of these little screws were £9.99, and I think 100 of these were about £6. So I can't complain at those kind of prices. Anyway, as I say, I'm going to go away now. Hope you understand what I'm trying to do. I'm going to go away now and try to build all of this up, and once I've done that, I'll be back and we'll try and show the point being operated by a live servo so that you can see what I mean. And we'll also put a meter across the micro switch so that you can see how it changing as the point moves, and hopefully I can move the servo quite slowly. I have a little servo driver here, which upside down, which just requires 5 volts on there, and it'll drive up to 4 servos in the end here, and it can produce a centre position, which is 1.5 millisecond pulse to get the servo centred, or it can produce a fixed position that is adjustable by this control, so I can move the servo slowly. And to prove the system, what you can then do is you can go to another position which will just continually operate the servo backwards and forwards, and then this knob controls how fast it does it. You can go shh, 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 or you can go, and various things in between. So we'll come back and we'll look at that pretty soon, I hope. Okay, I'm back. This is 2 days later, and I have a working system. It's not quite what I'd expected. It doesn't quite do what Dave Fenton's appears to do in his video, which, as I said, I'll put a link to. What I have is my power supply on these 2 leads, connected to my servo tester on these 2 leads, and on this lead I have the servo connected. The servo tester is from a company called HJ, and it's actually called a servo proving unit, I think. Not absolutely sure. Servo consistency test, it says on it there. I'll try and find that again on eBay for anybody who wants one, but if I can't find it, it may not be available anymore. I've had it a very long time. It's a very useful thing for testing servos. It's probably still available, and I'll try to help you out with it. The other thing is that I've got my multimeter connected across the one of the contact pairs on the micro switch. At the moment it says it's not on. If I turn this up to 17.5, too far, now it's connected, and at some point there, about halfway through the travel, at some point it disconnects. Okay, so if we do this, we're now operating. Slow it down a little bit. The meter is very slow to respond, I'm afraid. It's not the best meter in the world. It might respond a bit quicker there. No, it's very slow. It really does respond slowly. But you can see that it is operating and will eventually control the polarity of the crossing. So what we're doing at the moment is we're driving this from, as you can see the numbers, 2200 down to 800. They are microseconds. So it's going from 0.8 to 2.2 milliseconds. Now the normal thing that we do with servos for the full travel is we drive them from 1 to 2 milliseconds, which gives you approximately the 90 degrees. So we're actually overdriving the servo as we stand here. And if I tip this up, we have to move that out of the way now so you can't see it. If I tip this up, I'll just disconnect these as well because they really get in the way when you're trying to do this. Okay, turn that off. Right, so I tip this up, you can now see, turn it on its side a little bit, you can see the servo operating now. And you can see it's going more than 90 degrees, considerably more than 90 degrees. I'll operate the point manually again. So that is over one way. So the servo is here. It's not quite centred, unfortunately. And that's over, well, it's got 13, it's 11.50. That's over the other way. And you can see that the cam is now well across the micro switch. And that's 11.5, sorry, 11.50 to 17.50. And the micro switch breaks just either side of that, which is the centre. It is centred. I've got my numbers wrong. At about 14.50. So it's not far off being in the right place. What you can see though is that I haven't quite done what I expected to do. What I have here is I have a servo with a double horn on it. I had intended to put this wire into one of the holes down here on this horn and just use the single servo horn, which is what Dave does. But I couldn't get enough movement up the top here by doing that. But I found I could get more movement by shortening this distance, which is quite reasonable. The shorter this distance is, the more movement you get the other side, for the same movement effectively here. It's perfectly reasonable. But I'm still not convinced I can get quite enough movement. So what I've also done is I've spaced it off another 4mm. Now that isn't going to be a problem. I'll just get my piece of foam, which is not quite in reach. Okay. Sorry about that. Should have picked that up before I started the video. If I put my piece of foam flat under there, you can see, I hope, that there is still clearance at the bottom of this, even with that extra 4mm there. So I haven't overdone that at all. This cable will have to come out and go along the bottom of the foam. We'll sort that out when the time comes. What I'm hoping to do is to get it to work with this piece removed. This extra piece of 4mm removed. It isn't glued in, it's simply held in by the bolts that are holding the servo in place. Sorry, the mechanism in place. The screws actually are underneath there. Terrible. Are underneath these two here. One's about there, one's about there. And I've sunk them into the 4mm surface. Excuse me. They're M2 by 10s. So I've got 8mm. I've got 4mm here plus about 2mm here, which is 6, and about another 4 there, which is the 10. And they're just tapped into the bottom of this for now. What I will eventually do is make this easily removable and put nuts on the top, and actually try to in some way fix the bolts so that they won't come out. I'm not sure exactly how to do that, but that then means that once you've got the point laid and it's all ballasted, you don't need to get to the top to operate to undo the screws and take this off. If something was to break on here, or you need to remove the servo, really difficult to get to that screw under there, which holds the servo on. Even more difficult if you have to screw the new one in, because you've got to screw it into this material and you've got to tap it. They're just self-tapping screws. Anyway, so I have, as I say, a working system. We can make it go. That's about the distance it needs to travel. And if we operate it, try and get it facing you directly. If we operate it the way it was before, we go the full distance, you can probably see, especially if I stand that up, you can probably see how the wire is pulling downwards right at the ends, and that wire pulling downwards, of course, could pull it out of the tie bar. But I don't need to go that far, as we've discussed before. I need to go from there, 1750, to there, about 1350. Sorry, I always go 13, meaning 11. There, about 1150. So we have a lot less pull down on that wire. If we go a bit further, you can see how it pulls the wire down. Yeah, the servo works hard to do that because it's bending the wire. But I think, as I say, it's not quite there yet, but I think we have a workable system. So I'm going to wind this video up now, and I'm going to carry on and play with this, and in the next video, which won't be entirely devoted to this now, well, that's not the intention anyway, but in the next video hopefully I can show you this again and show you a more finalised version. But this isn't far off. This is a system that will work. It's just that you do have to adjust the throw, because if you don't, it's quite possible it could pull the wire through the tie bar, and we don't want that. So, thanks for watching. As I say, links in the description. If I can find a link for this servo, what is it called? Consistancy unit. If I can find a link for it, I will. I'll put it in. It doesn't actually make that horrible. It doesn't really show like that. Sometimes it seems to want to be very difficult. It's not really flickering at all. I can't see it flickering in any way. But with the lights in here, it obviously strobes a bit. It probably updates at about 60 Hertz, and the lights are at 50 Hertz, so we're getting about a 10 Hertz flicker, which is quite unpleasant. Anyway, we don't need to talk about that any longer. I have basically the start of a working system, as I say, and I'll be back as soon as I can with some more video. What the next video will contain, I really don't know, but I have had another problem with my Helljan Class 47, which I will be telling you about then. So, until then, thanks for watching. Bye.